Okay, good evening. Welcome to FawnMath number 5. This is a fun little geometry problem that FawnWin posted on the internet tonight. And I really like it, and I wanted to go through a quick solution because on her blog where she posted this problem, I saw a lot of people drawing in an extra rectangle up there, and I just happen to have a different solution. I'm sure this is a great solution too. I had a little bit different solution with similar triangles, so I just wanted to show it just in case it would be instructive. So the problem is, let me erase that because I'm not going to use that. The problem is you have a rectangle, a 16 by 10 rectangle, and a triangle on one side of it, and you draw the line from the corner of that triangle to the other side of the rectangle, and this area up here, this funny shaped triangle here, has an area of 24. And the question is, what's the area in this part of the rectangle here? That's actually a pretty interesting question. And what I'm going to do is I'm going to use similar triangles. And I'm going to label this little height here y, and this length here. So this small triangle here is going to have a height y and a length x. This side is going to be 10 because it's part of the rectangle, and then not 10, 16. And this height here, which is 10, and I've already got a y there, so this is going to be 10 minus y. So I'm going to set up a ratio equation with 3 similar triangles. The first similar triangle I'm going to look at is this big triangle here that has a height 10 and a length of 16 plus x. So the short side to the long side is 10 over 16 plus x. Now I've got this small triangle here that's similar to that triangle because it has the same angle, shares an angle, has the same right angle, so all 3 angles are the same. So it's a similar triangle. The short side's x, the long side is y, or sorry, I said it wrong. The short side's y, the long side's x, y over x. And then I have this triangle, this right triangle up here that shares this angle, which means this angle is the same as this angle too, because I've got 3 angles in a triangle, 2 of which are the same, so the third angle has to be the same. And the short side here is 10 minus y, the long side is 16. Short side is 10 minus y, and the long side is 16. So I have these 3 ratios that have to be the same because I have 3 similar triangles. Now I'm going to use the fact that the area of this triangle here, this triangle here is 24. The area of this triangle is the area of the big triangle minus the area of the small triangle. So the big triangle area is 1/2 base times height, which is 10. It's the area of the rectangle, minus 1/2 x times y, base times height, xy, and this is 24. Just to keep things simple, I'm going to multiply everything by 2 and get 10x minus xy equals 48. Sorry. And then I'm going to factor an x out of this and get 10 minus y, x times 10 minus y, and 48 is 3 times 16. And now I notice something. I've got an 10 minus y here and a 10 minus y there. And I've got a 16 to go with that 10 minus y. So I'm going to divide everything by 16, 10 minus y over 16, and I'm going to divide everything by x, equals 3 over x. Now why did I do that? 10 minus y over 16 is my ratio here, and that now equals 3 over x, but that also equals y over x. So now y has to equal 3. Yay! So y equals 3. And that, believe it or not, I don't even have to solve for x. Knowing that y equals 3 is enough to figure out the area of this bit over here, because I can draw in this line here, making a rectangle that's 16 long and 3 high. And then I have my triangle in here that's 16 long and 7 high. So this area that we're looking for is 1/2 16 times 7 plus 3 times 16. And that's 8 times 7, which is 56, plus 48, which is 104. Yay! 104 is the area. And we didn't have to draw in this other piece. And funny enough, I was kind of surprised, we didn't even have to know what x was. So that's kind of cool. So anyway, I thought that was a fun solution with similar triangles, and hopefully that's helpful. Thanks.